This is a video on implicit differentiation. The question states, differentiate implicitly to find the partial derivative of w with respect to y. And we have the equation, the sine of xy minus the cosine of yz plus xw squared is equal to 2. So to implicitly differentiate, we can use a nifty formula that says that the partial derivative of w with respect to y is equal to negative the partial derivative of f with respect to y of x, y, z, and w divided by the partial derivative of f with respect to w of x, y, z, and w, where f is the left-hand side of the given equation, where the right-hand side must be a constant. If we don't have a constant, we can always subtract off the right-hand side and set it equal to 0. So I just need to find the partial derivatives. So let's start out with the partial derivative of the left-hand side with respect to y. So for the sine of xy, I use a chain rule. The derivative of the inside, x is a constant, y is a variable. So the derivative of xy is just x. And the derivative of the sine is the cosine. So I get x times the cosine of xy. And then the derivative of negative the cosine of yz, the derivative of yz with respect to y is z, and the derivative of negative the cosine is the sine. And then for the derivative with respect to y of xw squared, there are no y's, so that's just 0. So what I get for the top is x cosine of xy plus z sine of yz. And then the derivative of f with respect to w, the first two terms don't have w's in them, so that derivative is just 0. And the partial derivative with respect to w for xw squared, x is a constant, derivative of w squared is 2w, so I get 2xw. So my final answer is that the partial derivative of w with respect to y is equal to negative x cosine of xy plus z sine of yz, all divided by 2xw. And I'm done with the problem.